where we have left, we are starting from that point now. Let me share my screen. So everybody is in a fresh mood to do a lot of mathematics today.
Yeah.
Okay. And is there any doubt from the last day's session?
No.
That's good. Share my screen. Okay. Last day, what we discussed is that there is a function or one-way function named hash function. We use it for uh, checking integrity of our data. And we have seen that how exactly we can see we can check the integrity of the data that we use every day when we download a file. Just give you another example. Say I have this is let me go to my download folder. Probably there will be something that might be interesting for us here. Okay, I can see there is a Ubuntu ISO file that is there in my hard disk. It is in my download folder, but I really do not know where I got it. I really do not know whether this is the legitimate version of Ubuntu or the official version of Ubuntu, or it is something else. I might have downloaded it from torrent. I might have downloaded it from some other site. Maybe some of my friend has given, or I do not know where it came from, but it is there on my hard disk, and I want to check whether this file is the official Ubuntu release or not. Because if somebody can get access to this ISO file or any other exe file, they can inject any malicious data in that. So I really do not want that. I want the original version that was released by Ubuntu. We can do that? This is a 3.4 gigabyte of data. So one way of doing it, just download another copy from Ubuntu official website and then copy. But that doesn't make any sense. If I download it from the Ubuntu website, then what's the point of using this file? And secondly, comparing 3.4 gigabyte data is a very laborious job even for a computer. So what we can do here, we can just find the SHA-256 hash for this. We just find the hash for this file, and it's taking so 3.4 GB. It's taking time, almost 11 seconds. It took almost 15 seconds, but that is for 3.4 gigabytes of data. We can call it pretty fast actually. So this is the SHA-256 data. This is the hash, and you can see this is not 3.4 gigabyte of data. This is just 256 bit of binary data. And now if I go to Ubuntu official release part 256. And if I simply go and we need to check whether this one is the same. Was my data? No, this is not. This is it? So what I find that this file that I have is not a legitimate one. It's not the, oh sorry, 22.04. I probably am checking it 20.0. Are you getting what I am doing here?
Entering the hash to check whether integrity of file is under.
Yeah, now this is my hash, the hash that I calculated, and this is the hash that is the official website says. So these two are same as I see. Okay. So this file, the file that I have is the right one. I don't have any doubt. So this is how we can create. This is one of the way that we can use the hash function, and this is how we can check the integrity. So this is not for confidentiality. This is just for integrity, that the file that I have is not tampered by anybody else. And one of the property of this function is it is one way, of course, because if you can find from the hash, you can really cannot generate that the big 3.4 gigabyte of data. It's not possible, and it should not be possible as well. And the second thing is, if you give any big data, any number of data, it will give you a fixed number of data or a fixed bit of data. So instead of binary function, so every function or every cryptographic function that we have discussed, it is applicable on a number. And we saw in our last class that everything is a number, be it a text file, be it an image file, be it a exe file, or even the entire cloud that is have running on Amazon AWS. All of them are just an endless string of zeros and ones. And if it is an endless string of zeros and ones, that means we can convert them into a number, a decimal number. And hash function, basically it is a mathematics. We can apply it on any number, or whatever big or small the number is, but it will give me a number within a fixed boundary. Or in binary world, we can say, you can give a binary string of any length, but it will give you an output of a fixed size. Fine. Everybody now understood what a hash function is, right? Hey guys, this is an online class, so I
Yes,
need
yes.
you guys
Yeah.
to interact a little bit. Otherwise, it will be too boring for you, and it will be more boring for me as well. Okay. Okay.
Yeah.
Let's. So this is for data integrity. And one use case we have just seen that the file that we have downloaded, whether this is correct or not. Most of the cases we download from different mirrors, we download file different exe files from different places, or song file or movie file from torrent, whatever. We just need to check whether this is the right file or not. For that, hash is very important. Second use case is a storing password. Let us see that. You know what is this? Any idea what is this?
Password of user.
Sorry.
ETC shadow file is stores used to store the passwords of users in the system.
Yes. So in any Linux system, it never stores a password. It only stores a
Hashes.
hash of the password. And this is the file where it stores. My system has a lot of different users, but none of them has any login. Only one user has a login, that is me. This is only Maity. This one user has a login, and this is the hash for this. Right. And if I put a hash in the file, what is the advantage over storing the password? I could have stored the password also. Why we are using hash?
I can't do reverse engineering.
Exactly. Even if this file is compromised, then also nobody can understand what is the password. There was no another way that long back Windows used to do. That is, uh, you can just simply encrypt your password and then save that encrypted password. But then also it is a problem. Somebody can steal the key as well as that ciphertext. Then they will get the password back. But here, since it's a one-way function, you can no way, there is no way that you can get the password. And uh, this this long string has actually three different parts. I'm coming to that. One is the delimiter is this dollar sign. Okay, you can see there are $3. That means there are three parts. Another one is saving state of system. What is that? That means when we save a game, especially the online games. That is a very good yeah, example. When you save an online game, what it does, it just entire system, whatever it is that is also nothing but an endless string of zeros and one. It calculates the hash and stores that hash somewhere, so that even if that state is tampered, anybody can find out. Virus can we all know, like all the virus can antivirus tools they use, they just store keep a hash for all the virus or the malicious code, so that if that file is there present in your system, you can directly find out. If you just go here, you can simply upload a file and it will calculate the hash and it will tell. So this is a out of band online virus scanner. If you have any doubt with any of your file, you can simply upload the file and it will tell you whether this has a virus or not. How it can tell that? It simply checks the hash of that file, and it has a very big database of hash of all the malicious files. Okay, and it just checks. Otherwise, there will be a file comparison, which will be a very, very cumbersome process and very long time taking process, but we don't need. Message authentication, will come to that, how the message authentication work. And today in the second half, we will discuss about blockchain as well. Okay, now we understood what is a magic function. What is this magic function named hash? It has to be one way. Last day we also discussed it in a different way. Like if Alice gives a function to Bob, just Alice picks a random number and it applies a function on that number and sends that output to Bob. Can Bob guess what was the actual number that Alice thought of? This is a thought exercise. Okay. I pick a random number. I'm not telling this is my secret number. I applied a function. And whatever is the output, I'm giving it to you. Can you guys find out that what is the number that I have guessed? Is it possible?
No.
Yes, yes, it is possible.
Okay. Is it always possible, irrespective of the function?
No, it has to be modulo function.
Okay, modulo function.
And,
Okay.
and number has to be prime.
I'm not talking about odd or even. Okay. Just take any function. Give me any function, Praveen. Any function that comes to your mind.
Modulo.
Modulo what? Modulo 10?
10 modulo 3.
Okay. So the number is 10 and I just make a modulo with 3, right? So it will
Right.
give me 1. And if I give
Yes.
you number 1, can you find back what was the original number? That is 10. Or I am giving another example. Just I am taking another function, say x square. X square is a function, right?
Hmm.
And all of us know this is x. Now I say I picked a number and I applied this function and I got a output 9. Can you find what number I have chosen?
2%.
Sorry.
If we know the function,
Okay,
then
I'm saying I have the function is, sorry for my handwriting, function x square. I took a random number, some random I have thought, and I have said, if my number say my number is let me say a, some number a, and I said if I do apply this function of a equals to 9. Can you find what is the value of a? Can you find it? Function of x is x square, right? And I said I have taken a number and applied the same function and got the output as 9. Can you guys say what is the number?
3.
3. In fact, there is a 50% chance that you can guess
Yes.
it's either plus or minus. But yes, it is 3. So it is a fair chance that you can win this game. If I take the function as x square, I can take the function as say another one like maybe 2x or say 23x, and I say I have taken a number, and if I apply this function, the answer is 46. Can you tell me what is my number?
2.
Very good. Now exactly again we are going back to Pravin's example. I am taking a number, say mod 100. Okay, and I'm saying I have taken a number, and if I apply mod 100, it gives you a output 46. What is the number? Can you tell me?
No, sir. With just output, we cannot determine what is the exact function or the input that was given to that function.
Yes. So so the I might have guessed 46. I might have guessed 146. I might have guessed 246. I might have guessed something 1, 2, 3. Only any number that has last 2 digit as 46 will give me this output when I apply mod 100. Is not it? So for this particular function, this function we really cannot get back the original x. But for the other function we can do. So this particular type of function that does not let me understand or let me guess what is the original number is called a one-way function. Make sense?
Yes, sir.
There is another nice one, odd or even. Or I can give you another, like if we want to apply hash on a person, maybe everyone has a birthday, and that birthday is a hash function on a number. If I give you a birthday, a particular date, it is very difficult for us to find whose birthday is it, unless we already know it from before. But it is very easy. Just ask somebody, "Hey, when is your birthday?" Or you can check any of the document and you can find out what is his birthday. So it is also finding birthday is a one-way function, right? Okay. So this magic function or this hash function will have one property which is one way. Can you give me some example of some more one-way function?
Yes, sir. How about some banking websites? Usually, I have seen that most of the banking websites, when we put the password and we click on login, the password and our username will change to a hash function. That hash
Yes.
function
Yes.
get checked from the database, not just direct the password or the username. That way, even if the database has been cracked, they cannot able to determine what the exact username and password for that particular account.
That is the application of hash. I'm just asking whether can we guess any other function. So now, right now we are not going into the application. At this point of time, we are trying to understand the mathematical aspect of the hash function. Asking you any mathematical function like x square, 2x, mod 10. So these are different hash functions. These are different functions we have discussed. And from that, we have found mod 10 or mod 100 is a hash function. Can you give some more hash functions? Everybody will give me some one and some other one-way function. Some one-way mathematical function.
We can have logarithmic functions.
Okay, like
10 log 1.
just give me a second, please. I'm trying to open the one now. Just 1 second, please, so that we can do some whiteboarding.
Sure, sure.
Okay, now this is hash property. Okay. Hash properties. An example. One of the the first hash properties that we have discussed is it should be one way. Right? And one example that we have already found is mod something, mod any number, right? Any other, you said log. Can you please tell me the function that you just said, log?
Yes, sir. It's just like y equal to log x with base z.
Y equals to log x base g. How is it? That means
I don't exactly remember how the
that is this, right? Y equals to
result.
y equals to x. Yes.
No, x power z equal to y. I think.
No. Y equals to log.
No, it is sorry, it is g power y is equal to x. That is
Yes, yes. Thank you. I'm just a power y equals to x, right? Okay.
Yes, yes.
Yes, you are right. This is very difficult to find. This log x base a, unless you have a log table or a calculator. Calculator is nothing but a log table, like implementation of log table. So if you have a log table, then this is very easy to calculate. But if you do not have a log table, then it is really very difficult for us to calculate. But it is difficult. But this can you consider it as a one-way function? The answer is no. It is not one-way function, but it is very difficult to calculate. We can call it something called a trapdoor function. Today we'll see what a trapdoor function is. This is actually a trapdoor function. This is not basically this is not a good one-way function because you have the inverse function existing, but it is very difficult for us to calculate. That is a different thing, but we can calculate. But when we are doing a mod n, we really cannot calculate. It's not possible. If I just give you 46, you can never tell me what is my number. It is mathematically not possible. There is a delay when I'm writing here and it's coming here. It's
Yeah, for hash mod will not use.
yes, for hash, this function cannot be used because it is really not a one-way function. Okay.
It was for actually key exchange. I misunderstood.
Yes. Now, any other function that it comes into your mind? Any other one-way function? Anybody give me any other number? Any other number, not number, of function, any other function that is one way? Okay. How about this one? Is it a one-way function?
What if
Can
we do
anybody?
the sine inverse?
Yes, we can do the sine inverse. But the problem here is, if you can remember, sine 30, sine 30 is 0.5. Again, I guess sine 120 is also 0.5. Again, sine 390 is also 0.5. So I calculate, I took say 120. 120 is my number, and I applied sine 120. I will get 0.5. Now, if I give you this 0.5, you can find sine inverse 0.5, but the answer might be 30, 120, 390, and so on. There are thousands of different numbers which will not thousand. In fact, the infinite numbers are there which has the same value 0.5. You are getting my point. You remember this,
Yes, I got it.
Kiran? The trigonometry. Kiran, are you there?
Yeah, Chris just responded. So
Yes, sir, I have been responding.
Okay. So now this is the trigonometry that you asked, that where we can get trigonometry for cryptography. So this sine or cos will be one-way functions. Okay. Okay. Now let's go to our presentation.
So for MD5
Yeah.
SHA1, which functions are used? This trigonometry functions or something else?
We'll see. We'll just like last day we have seen that how exactly the block ciphers come, and then the fiscal cipher, ES, DS, everything we right. Today also we'll start with a very basic functionalities, basic hash function. We'll try to create our own hash function, and then we'll see actually how the MD5 or SHA-256 works. Okay.
Okay.
Okay. Now the second property of this hash function is it should be collision resistant. It sounds very why what does that mean? What is this big jargon means? Collision resistant. I'm coming here. Collision resistant. That means
For more than two output input, there should not be one single breaker.
come again, please.
So for more than one input, there should not be same output.
But is that really possible? Why I am asking? Okay, there is one more function that I have not written yet. Before that, I'm just one more property I am writing, which is fixed output, fixed length output. Sine cos are actually would hold this property as well. Why? Because the value of a sine is -1 to +1. It always lies between that. So it has a fixed length output. Makes sense, right? Okay. And the third property is collision resistant. And you said that means even if I x and y and I apply the function, this will never happen, right? Is that what you just said? Here we are here.
Yes.
But is that really possible? Why? There might be any length of input. This is a function, any length of input and a fixed length of output. Just imagine that means, say I am taking any length of input and output is always say 4 bit. And I can give any length like it might be 8 bit, 16 bit, 32 bit, whatever bit of input is there. And output is always 4 bit. If that is the case, is it really possible that two output will never be same? You are getting my point.
Yeah.
It is like
Yeah, it could be same.
There has to be same, otherwise we really cannot make this function. It is mathematically not possible, right? It is as good as like there are 4 boxes and say you have 8 PGN. So of course, to accommodate 8 PGN into 4 boxes, you have to put 2 PGN in each of the boxes, right? You cannot have 4 like each PGN will not have one single box, right? If there are 16, each box will have 4 PGN. Make sense?
Yes.
Yes, sir.
Yeah, yeah.
That means it is really not possible because of any input we are giving any length, but we are always getting an output of only a fixed length. Here in our example, it is 4 bit. That means 4 bit represents only 16 numbers. So whatever number I give, we have to map them with any of these 16 outputs. Okay. Another good example, probably you have never thought in that way. Say in any competitive exam, maybe CET. Okay. In CET exam, how many students will have the same number? Any idea? Like any random guess, how many of them will have the same number in CET exam or IIT mains exam?
You mean like roll number?
No, marks.
Percentage marks. I think 25%.
No. How many of students? Like say there are. I'm taking another example. Say
So
0
out of
to
100, 25 would have the same number. Same marks.
Around 25, 26, probably the 25 students will have the same number. That's what you were saying, right?
Yes, yes.
Okay. Now let us take a simple example. How many number CT exam? What is the marks of total marks of CT exam? Pranav, you have given a CT, right? What is the total marks like exam of what is the full marks of that exam? It is 100 or 300?
Yeah, I think it's 180.
180. Okay, 180. That means how many possible outcome of this result? Any student can get any number from 0 to 180. Either they will get 0 or they will get 180. And 0, some student will get 1, some student will get 2, so on, right? So there are total 181 possibilities if I include 0. So there are total how many possibilities? 181 possibilities. Right? Everybody is with me?
Yeah.
Yes.
How many students are giving the exam? Around 5 lakhs maybe? I don't know.
Yeah, 5 lakh.
So you have 181 marks and you have to distribute them between 5 lakh students. How is it possible only 25 students will have the same marks? 5 lakh students. That means 5 lakh divided by 181. That is the average in one single marks. That is the average students will be there. Like that many students. Yeah. So 5 lakh by 181, as you see here. So in every marks, probably that many students are there. You are getting my point. So it's not 25, it's much more than that. 5 lakhs, I am distributing 181 marks. Total, I have possibilities, 181 possibilities. And every student will get one of those possibilities. And there are 5 lakh students. So if it is 5 lakh and we have 181 possibilities. When I am taking if there are negative marking, I am taking 200 possibilities. Then also in every mark there are 2,500 students. So the person who has stood first, whose rank is first and whose rank is 2,500, probably this is a very possible case that both of them got the same marks. You are getting?
Yes,
Have
sir.
you have you thought in this way? Like the person who stood first, whose rank is first in CET and whose rank is 2,500 in CET, both of them might have the same marks. In fact, that is the if it is a normal, like if it is a average distribution, then it is like that. If I assume that everybody will get the same marks, it is evenly distributed. Then in every marks there will be 2,500 students. That is 2,500 students will get the same marks because I have total possibilities 181. We do not have more than, we cannot give any other numbers to them. We have to give one number out of these 181 possibilities. And we have 5 lakhs students. But in general, like when in practical, it is a normal distribution, it looks like this. So maybe in the like the guy who has get the 100 percentile, that is the highest marks, probably there are very few students, maybe 2 or 3. And the person who got 0 or the maximum negative, whatever is the lowest score, there is also 2 or 3. And more you go towards the average, like to the mean value, the number of students will be more. So if we actually get the numbers that is never get published, be it JE, be it CET, whatever, it never published. If we get the numbers and the ranking distribution, probably the person who has 1,000 rank and the student who got 10,000 rank, probably they are having the same marks. So did it blow your mind? Have you thought in this way?
Actually, we did once, but after that, since we didn't get that, we just left it.
But that's why they move to percentile kind of a method, no?
Percentile is also the same. Percentile means it's just the highest marks they have divided by my marks into percent into 100. So that is but the possibilities are always same. If I have 180 total possibilities to distribute. 180 total numbers I have. And I have to distribute this 181 possibilities among 5 lakh students or 10 lakh students. If it is JEE, there are 10 lakh students. If it is NEET for like medical joint NEET, then there are, I think, some every year some 20-25 lakh students are sitting there. And I have total possibilities, 180 total possibilities. I have 180 marks total. I do not have many. I cannot give anything other than these 181 possibilities. So anyway, there will be a lot of students. In fact, thousands, 10,000s of students in the same marks. That has to be there. So even two students have the gap of 10,000 ranking, they might have scored the same in the exam. Okay. So this is called hash collision. So this is a hash. Every student will get a marks which we can think about a hash because that has 181 possibilities. But number of students is infinite or it is a very big number. Any number of students, but I have always 181 possibilities. I do not have any other possibilities to give them. So this is a hash collision. This is bound to happen if you have a fixed output and infinite input. It is bound to happen that there will be a collision. Make sense? So yes, two number might have same hash value, and that is bound to happen, and that is quite normal. So many people think that hash means every different input will have a different hash output, or every uh, different input will have different hash values. The answer is no, that is not possible. Are we on the same page? Are
Yes,
we on
sir.
the same?
Yes, yes, yes.
Okay, so this is not possible. We understood. So then what is collision resistant? The collision resistance is I cannot given a X. So what we discussed, if there are two input X and Y, and this is a hash function, this function we are calling hash function. This if this is equal, like for X and Y, for a given X and Y function of a hash of X equals to hash of Y. This is bound to happen. But what should not happen for a hash function, for a good hash function, given a X, function of X or hash of X, maybe hash of X, we really cannot find what is the other number which will have the same hash. Got it? So yes, there are other number which will give the same output, the same hash function. Say I'm taking a number and I'm applying hash on this two. So maybe this is giving me 1011 something 4-bit hash happening on this. Now it is what a good hash function should be. I cannot find any other number, even though I know two, I know what is the output, but what is the other number? I cannot find the other number which will have the same output. There are other number that bound to happen, but what should be there? I cannot figure out, or it cannot be mathematically computable that what is the other number that will also have the same output, same hash value. Make sense?
We can take example
Yes, sir.
of X square on the exam.
Okay. Uh,
So function, if a function is X square, output is 9. So we have obtained that output from input say 3. Other input might be -3 will also give us same output, right?
slow. I
Should
am
not.
writing what you are saying. So please just speak slowly. I just missed you. Can you please repeat?
Yeah, function is X square.
Okay.
Okay. our output is 9,
Output is 9. Yes.
input is 3.
9. I can find out input is 3. Yes.
Input is, what we have given is 3, but other input might be 3 minus 3 also.
Minus 3 also. Exactly.
Yeah. So from 9, we can, even though we have given 3, we should not find out minus 3. Like function should be collision resistance if we were not able to find minus 3, right?
Exactly. That is the one. Exactly, that is what I am saying. Even if I can find 3, I cannot find minus 3. If that is that, if that property, we can call it collision resistant. Clearly, x square is not like that. Even sine cos cannot be there. That because we cannot find the other. We can find because there is a pattern. We know that it is 30, 120. So we can find that pattern, right? Even mod n will not also work because there is even though I know mod 10, so I can give any number, say 40, 55 mod 10 equals to 5, but I can immediately find 65 mod 10 will also be 5, right? So that's why this is also not a good hash function. Make sense?
Yeah.
Okay. So this is called collision resistant. Now we are stuck here. I really do not know whether we have any other like can I figure out any other good hash function that will also be collision resistant? Anything is coming in your mind which is collision resistant? For X I cannot find Y. The other values we cannot guess. Okay, we'll see whether we can create our own hash function or not. We'll see that. Okay. So these are the different properties that a hash function should have. Other properties, the three main properties we have already discussed. One is this one, another is this one, and another is this one. So it should have fixed size output, it should be one way, and it should be collision resistant. There is something called weak collision resistant and strong collision resistant. I will explain that later. Now this any book if you open, exactly this statement will be written. So now we understand how to read this statement. What is the meaning of this statement? Make sense? For any message, we can find the hash, but we cannot find any other message which will have the same hash. So this simple thing is always written in this format. If you study like open any book, this is the exact terminology they will give. Now we understood this. What does it mean? We understood what is the meaning of one-way function. We understood what is the fixed size output and what is the meaning of a fixed size output. What might be a problem with a fixed size output. Now there are two more properties that a good hash function should have. One is it should be very fast to compute. If it takes a lot of time, then if we give a very big input, maybe 3.4 gigabyte, I have shown you. For 3.4 gigabyte, it took 15 seconds, which is still okay. But if it is not a fast function, then it will take like maybe hours to just compute the hash. Then that really doesn't make much sense. So it should be very fast to compute. And the last one is avalanche effect. That means a small change in the actual text will change the hash value completely. Even one bit. So the basic expectation here is if one bit is changed in the plain text or one bit is changed in the message, that should change half of the bits in the hash computed hash. Half of the bits. Okay, that is called the avalanche effect. Avalanche means a small change, but that has a very big effect. That's why like one message, you will get a lot of change in the almost half of the entire hash value will change. Makes sense? These are the 5 properties of hash functions. And everything we understood now. We understood what is a hash function, how it should work.
Yes, sir.
Okay. Okay. Now let us create our own hash function with this knowledge. Let us try to create our own hash function. Okay. Let us take up how many bit? 4-bit hash function. Let us create. Okay. 4-bit hash function we are creating. Give me a input, any input, 10 string. Just tell me 10, some random now, 1 and 0. You just give me 8-bit or 16-bit, whatever. 16-bit, you just give 16 bits for me. Anybody?
110
1 1
100
1 0 0
1
1
000
0 0
111 0
0. How many? 1 2 3 4 1 2 3 4 1 2 3 4. Probably
8 12. Okay. 1
One, one,
0
one.
1.
okay.
Yeah.
Now we got 16 bit, and we have to create a hash which will have 4 bit. Okay.
Okay.
So now what we can do? We can take every 4 bits from here in the input, and we can simply XOR them. Can you do that? The method 1 1 1 0 1 0 0 1 0. Let us XOR it. 1 1 1 1. Right?
Mm.
Then again 0 0 1 0 0 0 1 1. Right?
1. Yeah.
So 0 0 1 1. Again I am XORing. And again the last one now. 0 1 0 1. Again I am XORing. It will be 1
Zero,
0.
zero.
So this is hash value. We can call it, this is a hash value.
Yeah.
Just imagine, if I give you 1 0 0 1, you can never find out what was the original input. Can you? It is one way. Secondly, if I what are the other properties we have? It's fixed length,
Fixed
less
length.
fixed length. The third property, if I give you 1 0 0 1, can you find any other number which will give you the same input, same XOR? It is difficult.
Yes.
Yes, we can craft some numbers. So this property does not hold, but this is difficult, quite difficult. It doesn't really have a pattern, but it is. But we can find. But if it is, since we are talking about 16-bit and 4-bit, it's quite easy. We can just using some logic, like using the same logic, we can do it on pen and paper. But imagine if it is 512-bit of data, is it really possible? And the on 3.4 gigabyte of data,
And that
it is,
is
that
not
is
possible.
difficult. It's still possible because the logic is there. Okay, I'm writing, but not always it is coming here. There is a lot of delay. Okay. It's okay. It was true. Okay, now it came. So, yeah. Just, So 3.4 gigabyte of data and 512 bit. It is difficult, but still it is possible. So it is, so the first hash function that we have thought is not a very good one. Okay. Now let us come to the second hash function that we can generate. We'll take the same input. What is that? One zero one zero zero one zero 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 one 101. I'm just disconnecting any disk, another again connecting. It's taking a lot of time for me. So, disk. You guys can still see my screen?
No.
And now we are able to see.
Now we can see.
Okay. That's it. Start now. Okay, this was the original number. Now we can do one more thing. We can just split it into two and then again do the same XOR operation. 0 0 1 1 0 1 0 1, and then we'll find something. So maybe 1 1 1 0 0 1 1 1, and then again split it into two and again XOR them. 0 1 1 1 1 0 0 1. Now this is a little bit difficult for us to make a collision, make it collision resist, like to find out the other collision values. Okay, because now we have split it into two. It totally depends on the input values. But still we can craft that. This is weak collision resistant, because given a number, I really cannot find the other number. But if I am asked to start it from the scratch, we can find two pair of numbers which will have the same hash values. It is little bit more difficult. Now you remember we learned something called S box and P box last day. You remember? That means each of these bits will bit position we will just jumble up. How about apply the same thing here in each step? This S box and P box. We can after this XOR we can again pass them through S box and P box. Again S box and P box. How does it look like? Will it work?
Yes, sir.
Yes,
It can be
should
work.
work.
In that case, the reverse is very difficult. Is not it? So it looks very much similar to that block cipher that we have used last time, but instead of having any key, we are just doing we are making the operation only on the plain text. Whatever input we got, on that only we are doing the XORing and then applying the S box and P box. In that case, we can actually create a very good hash function, but it will not have the avalanche effect. What does that mean? If I change one single bit, it will not have much impact on the entire output. That problem will be there. And yes, it is very fast. Whatever we are doing, we are using XOR operation, which is very fast undoubtedly. But this one will not be hold. That means even if I just change, say, the last bit 1 to 0, I just this one I just replace it with 0 maybe. In that case, only this value will change. And some S box, P box, after applying S box and P box, some of the values in this one, only one bit of this output will change. That means here also only one bit will change. So if I change one bit in the output, also one bit only change, nothing much. You are getting what I just said? Or things are becoming too much to understand in one day?
No getting, but this S box and P box
Okay.
application and the function, uh,
Yeah.
is there any, let's say we have chosen the fourth bit or the first bit.
Hmm.
Is there any formula to choose that, or it's a random
So
selection?
it is not a random, it is a formula, but the cipher designer, whoever is designing the cipher, they can come up with their own S box and P box. Last day we
Okay.
have created our own S box and P box, and it is a design time, one time design, but design time it is random. Somebody can come up with a random whoever is designing the cipher. But once it is decided, then it is decided. Then for the use case, like for the users, it is not random, it is fixed. But for the designer, it is random. Okay.
Okay.
Okay. And we understood that why this avalanche effect is not working here. Did you understand
Yes.
that? Okay.
Yes.
Okay. So now we have the hash functions. We know the properties. We have tried to create a more or less good hash function. Now we'll see that what exactly the hash function would work. Okay, this is a little bit in the mathematical term. We sometimes call it is a many to one mapping. We understand that there are like input might be anything and output will be a fixed 10. That means it is always many to one mapping. That is two different values will have two different number will have the same hash values. It is the event distribution, that is like if it is a collision resistant, we can prove that inside the set it will be the output will always be evenly distributed, and it is efficient, that is hx should be easy to compute, but the reverse is not possible. Okay. I'm not just now. Let's see how this now let us see some practical example. Uh, Now give me any number, any text. Just let us start with some of your names. Say Parth. Parth is here. This is the hash value for Parth's name. Okay. And I just change one single thing from here. Okay. Just I add a dot. You see the enter You are following me, right?
Yes.
Entire thing is changed.
Yes.
Just removing the dot and adding a dot. The entire thing is changed. Now I'm just giving some random. Whatever I am writing, it is always giving me a fixed output. It is a SHA-256 that I am computing. Okay. So this is the hash output is called hash values or digest or checksum. All these different terminologies we use. And this is always a fixed length, whatever doesn't matter, whatever input we give. Okay, XOR every k bit, that is we just taken an example with 4 bits, right? Every 4 bit we are XORing, right? That is one good hash function. Now one more thing we can. Last day we have learned about DES algorithm. How about giving a key just 0? It is a fixed key, 0 key. All the 256 bit of DES, sorry, 64-bit keys of DES are 0, and we can apply, we can compute the hash value out of that. If we give a fixed and known key to DES algorithm, if we provide that, then also inside DES it is doing that XOR, it is doing the same P-box S-box algorithm. It is using a Fistel cipher. Actually, S-box, P-box are there. Block cipher, it is not a block cipher, it is a Fistel cipher that we saw last day. You remember? It's here. This is a Fistel cipher we discussed last day, which DES uses. So there are S-box and P-box. There are different logical operators they use instead of only XOR. It uses XOR and or lot of such operation, and then it XORs with a second half, and then keep on doing that for different rounds. We learned it last day. Similar S-box and P-box operation it is doing. So we can do the same thing, but instead of giving a key, sub key or key, we can just send all zeros. Then also everything will be jumbled up. Makes sense? Will it be a good hash function? Tell me. Will it be a good hash function if I use keys all 0? Any answer?
Yeah, it would be a good idea.
Okay. All the 5 properties will be hold.
Mm,
Okay, we'll see. Quick collision resistant, yes, it will always hold. It's really a good hash function. It should be. It is one way, undoubtedly. It is collision resistant, undoubtedly. It has avalanche effect because that is one of the property of a perfect secrecy. That if one bit of the plain text changes, the cipher text should have half of the bits changed. That DES already DES satisfies that conditions. But is it really fast? Answer is no.
no,
And the second problem is output is as big as the message,
no fixed output.
right? That's a problem. If we give an arbitrary number and always will get cipher text as an arbitrary number, so it is not a fixed length also. But that problem, the last problem we can solve. How we can solve this last problem? Any idea? This problem we can still solve. We did that last day also. So this is the problem. We always have a plain text and we always have the cipher text. But we can actually put this cipher text, instead of taking this cipher text, we can put this in the next iteration. And then again the cipher text, instead of taking out this cipher text, we are not considering the intermediate cipher text. Only the last time, only for the last block, we will get the cipher text. So that will be a fixed output. So this is always a fixed, say it is a 64-bit. If I am using a 64-bit hash function, so the last 64-bit of the cipher text we will consider, because we are always breaking it into a chunk of 64 bits, 64-bit block, right? So only for the last block output we will take, because the previous blocks output are already fed into the system and getting a XOR. Makes sense. So that problem we can solve.
Yeah.
But it is very slow. It is not that fast.
Correct.
So the cipher with a block, the cipher blockchaining, we can solve the problem, but it's still it's very slow. But yes, that is also used, like DES as a hash function, DES with 0 key. Yes, it is used. Now let us come to MD5 hash. It's similar to DES. It's almost similar to the not no, sorry, not DES. It is based on a AES. It is AES. We have seen how the AES work. It actually breaks everything into different 4 chunks, and all these different logical operation it works on this green box, and then it arranges, and then they do all the XOR. All these things are XOR operations. So it takes the message, it takes the key is always 0, set to be 0, and we will get a output. And again, this output again will come here. And it is the message is broken into different blocks. MI means like is the ith block. It's first block, second block. If it is 64-bit, then it is the entire message is broken into 64-bit chunks. And MI means like when we are considering the first block, it is I is 1. When second, it is 2 or 0, 1, 2, whatever. Got it? And these are the different rounds. And also, if you can remember what we read in AES last day, what we discussed, it is very much similar to that. Then MD6 was also came in 2008, but MD6 was not popular. In fact, it has some problem. MD6 it uses markletry. Markletry we'll learn when we learn blockchain. What is markletry? But MD6 has an implementation issue for that issue. MD6 was also not adapted widely. But MD5, even though it is now deprecated, NIST is constantly telling that please do not use MD5. But still, believe me, how more than half of the applications, more than half of the websites are still using web applications are still using MD5. In fact, Linux and all, they are still using MD5. Many of the Linux distributions are still using MD5 because that is so popular. And SHA it's also very similar to AES. And there are different operations. So these are different people. Instead of P box and S box, they are doing a lot of shift operation, then XOR, and all these operations they are doing. Simply they are jumbling up the entire thing, and then we are getting a hash. Okay. So just the way we discussed the previous days block ciphers, it is also hash is also kind of a hash, kind of a block cipher without a key. So that's why hash is very often called as a keyless encryption, because the internally it is the same S box, P box, same kind of arrangement, same kind of XOR operations are made on these hash ciphers. So it is many of the cases the same ciphers are used, but with little bit tweaks, so that the output is more and more randomized, because here confidentiality is not the goal. The goal is integrity. That's why more we can make that jumble up, more we can rearrange those bits in the output, it will be a safer hash function. SHA-3 is also there. SHA-3 is also not very popular, but it is also a very an acceptable hash function. We can use SHA-3 as well. we have just seen how to validate a file checksum. We have started with that example. And if you want to see a comparison on the comparison of different hash function, you can go to this Wikipedia site. Okay. Blake, Haval, Indified, Shah, all these things. There is a very nice comparison, I think. Yes, here is a very nice comparison that how fast, what is the block size and everything. Okay. Now we'll finish hash in the next we have I have only couple of slides and then we'll take a break. Okay. Now let us come. So hash function as a mathematical function, hash is clear to everybody.
Yes.
Yes, sir.
Properties of everybody. Why we are calling these 5 properties and how these 5 properties are we can check any hash functions with these 5 properties. It is clear to everybody. And thirdly, how we can create different hash ciphers, that is also created. I'm not gone in very details of those block ciphers because that will make this class very boring. We have already touched all these things in the previous class for AES and DES. It is using the similar kind of block ciphers. Okay. It looks very similar. In fact, this is a keyless encryption. So till now everything is clear. Is there anything that we are missing or we couldn't understand better? We couldn't understand properly. If there is anything, please let me know.
No, sir, we are good.
Okay. Okay. Now we will see another application of hash, which is I am sending it is during the communication. The objective is not achieve any confidentiality. I'm not sending any secret message, but I want to make sure that whatever message I have sent is the right message. Nobody has tampered that in between. Anybody can read that message, I don't mind, but nobody should tamper that. How I can do that? For that, we can take the message. There are 2 ways of first simple Mac is like this. When we have a message, the sender is sending, it simply creates the digest of the message or the hash, apply a hash function, send the message, send the hash function separately, and the receiver receives the message, and it in out of in a separate channel or a separate communication, he got the MAC, got the hash value. It applies the hash function on the message, finds out the hash, and checks whether the hash is safe. And a little bit better approach, but that has a problem because the eavesdropper, he can change the message as well as the hash value. Then what is the better approach? Let us instead of making it keyless, let's have a common key. That is a good way. Even though that key is known to the attacker, it's very difficult for him to create the similar hash. Why? Because we know it is collision resistant. So we have a message, we have a key, and we apply the hash and then use the key, and we create a message authentication code using this. So we have hash with the same key. We just encrypt that hash and we create a message authentication code. And it is a symmetric key operation. So the same key should be there with the receiver, out of band communication of the key, either with Diffie-Hellman or physically they would meet and exchange the key. And receiver receives the message, applies the hash on the message, creates the same MAC value and checks whether the MAC value matches or not. Because MAC is appended with the message and they can check. Does it sound good? Is it a good approach for sending a message to ensure whether everything is intact? There is no tampering on the data. Is it a foolproof method?
Can you once repeat the
Okay, I'm just going to the whiteboard then. Okay. Say this is the sender. This is a receiver. Sender and receiver decides that let us have a common key. Sender says, okay, I have a common key 1010. Receiver also has the same key because they have already exchanged this common key. Oh, it is not coming. I don't know why it's so slow. What is happening? It's disconnected. Okay. So this is the common key we have, right? This is a common key. The common key. Now sender says hello. The message is hello. And it it creates a hash on this hello in this message. This is a message. What it does, this is the message. It also creates a hash. Say the hash is 101, whatever. I just assume this hash is 101 and 1010. And it create and it's encrypt that hash with the same key. Maybe AES encryption or whatever. Just taking a different hash function. 1110. This is a hash. We are just assuming this is the hash on this message. If we apply hash on this hello, we'll get 1110. And then we'll encrypt this hash with the key. So 1110 and 1010. If we just XOR, let us, for the time being, let us assume that the encryption is just the XOR operation. 0, 0, 1, 0. So this is the encrypted format. Now, what this is what we'll call MAC or message authentication code. Code is 0100. This one. Now, sender doesn't only send the message; it also sends a MAC. So what he sends is hello and 0100. This is the entire message he sends.
So we cannot able to see that.
How can I solve this problem? Why? Do you know any other good remote desktop software other than AnyDesk? It's very unreliable. Okay. Now we got, this is the message that that the sender sends to receiver. Receiver receives this message. It understood, immediately understood. Hello is the message. I'm just changing the color. It immediately understand hello is the message. And MAC is 0100. Fine. What the receiver will do? It will take the message and apply the same hash function on the message. He will also get 1110 and then decrypt, sorry, and then encrypt the message with, encrypt this hash with the same key, the same key. So 1110 and 1010. 0010. This is the MAC value he gets. This is the MAC value he gets, and this is the MAC value he got. So if these two are same, as we see, these two are same, this is the original message. What will happen if somebody just changed something? Like somebody has changed. Let us consider a scenario. Receiver gets a message something like beware. So, and the MAC value is 010, 0100, whatever it gets, but the H of M will not be the same. It will not be 1110. It will be say 0110, something like that. And then he encrypt this one 0110, and with the same key 1010, he will get 0011. So this will not match with this what he gets. This will not match.
So we only want integrity of that message. Doesn't mean we have to keep it a secret.
Sorry.
We are only looking for the integrity of the message, not the secrecy of that message.
Yes, only the integrity. Secrecy we are not also bothering here. It is only for the message integrity. Nobody can tamper. Make sense? Now is it clear?
Yes, we got that.
Okay. Now this is so far so good. It's very nice. We got a very good hash function that really cannot be reversed. But what about some mischievous guys who does something else? It's one way. Of course, one way is very easy. We can easy to compute the hash on a message, but it is really not possible to find out the message from the hash. And it is not possible for us to find a collision of the hash. When the hash collision will happen, we really cannot find, because it is a collision resistant. But some mischievous guys, what they do, they just create a database. So there are some mischievous guys. If you can go here, you can find a very big database of few hundred gigabytes of data, MySQL data. What they do, they simply create one-way hash of any number, any possible number, any possible password or anything. So any possible dictionary words or even non-dictionary words, they keep on creating the hash and store that in a database. And whenever you want to make a reverse, you just do a reverse lookup in that database. Makes sense what I just said? I'm just coming. Yeah. Here we apply a hash function on Fox and get these digest. This is the hash value. The problem is from this hash value, we can never get this Fox, this particular text, right? We can never get this text from this hash value. Now somebody, what he does, he just creates a table where he writes Fox has a hash value this one. This particular sentence has a hash value this one. This particular sentence has a hash value this one. All this, he creates a very long table of almost all the possible dictionary words, or even some of the brute force, any random numbers, random alphanumeric character. They just took and create the hash and store them into a SQL database or any table, just even as an Excel file also. Now I do not have any mathematical way to find the actual input from this digest. But now we have a table. From that table, we can just simply do the reverse lookup and we can find, okay, this is the hash, and now in my table, I have already stored this. The input would be Fox. If you like for this input, this will be the digest. I can simply find. Now everything is broken, right?
Yes.
You understand my point?
Yeah, just comparing the hashes and.
Yes, it's just comparing the hashes and do the reverse lookup. Just a table. I have a table. I can just find out what is the.
Yeah, already input values are there. It's just the comparing the hashes.
He has already computed that those things, because one way it is possible. I can create this digest from Fox. So somebody has created, what they did, they just run a program, all the possible words, all the possible alphanumeric characters. They just keep on doing calculating the hash and store them into a table. Now from that table we can find it very easily.
Yeah, it is possible to crack if the hash is there in that database.
Yes, if that hash is already computed by them, it is very much possible. Now let us try to find out. Give me a very common password that people use. What is your password?
Password -123.
Not even hyphen. Password 123.
Okay. Okay. So this is the SHA-256. I just created this password 12123, and this is the hash. Let's see whether this is already there in their database. There is no mathematical way that we can find it. It's already there.
Even admin.
Sorry?
Admin.
Admin. Okay. It's coming, right?
Yeah.
So it's very difficult for us to crack. Sorry, it is very difficult for us to create a integrated system, because somebody can do this mischievous act. It's a very simple way to attack crack. I do not need any mathematical knowledge, nothing. So the mathematicians, they work day and night and come up with the best hash function. Hey, this is the best hash function we can create. We created, and it cannot be reversed. No, there is no mathematical way by which you can find add this value admin from this hash value. The mathematicals work day and night, but some mischievous smart guys, they did a very simple trick and they find it. Okay. Now how we can solve this problem? Any idea?
Salting.
Okay, what is that?
So with like I can have password. My password will be password 123. But while storing or generating hashing, I will use some random say string, which will be with that password, and then create a hash. And while storing the hash, I will store the salt value also. So as we have done some minor change also in input string, hash will be so much different because of avalanche effect. So
Yeah.
due to salting, okay, yeah, and we will store whatever you have additionally added. That will we will be storing with hash. Now you won't be able to crack what will be the password.
Let's see, probably it will not find. Yes.
Yes.
So what I need to know, I need to store this salt.
Yes.
Where it is stored, it is actually stored here. So this is my shadow file. This is my hash. It is encoded with base 64, and this is the salt. And this is the hash algorithm that is used. 6 means SHA-512. Okay, 1 means I think ND5. So there are so different values represent different hash algorithm. This is the salt, and this is the hash value. So now we cannot find this. Got it? Everybody understood it? This is a random string that I generated and appended either I can prefix it or affix it, whatever. Either before the text or after the text I can. Okay, everybody understood it? Are you guys with me?
Yep.
Yes, so we understand, but can you please go to the previous slide?
Slide.
Slides. Yeah.
Just opening this one.
Okay. Where you have shown no, where you have shown the rainbow table, right?
This one?
No, sir, you have shown the rainbow table. It might
Oh,
be from different slide. Yeah.
okay.
So what is the x-axis that is it represents?
Okay, here this
Is
is
it
the table. This is not the rainbow table. This is a table that says that how long it will take to how long it will take to create that database. So it NTLM is a hash function. MD5 is another hash function. If we have 17.77 terahertz machine, then length for password can be like immediately instantly cracked. Even length 7 also instantly cracked. If it is a password length is 8, then it will take almost 6 minutes 14 seconds. If we sorry.
so it depends on what kind of hash value that we are storing, right? What
Yes.
if yes, what if we use let's say a rar5 from this one from below? Why don't we use that for storing passwords for almost from every website or any database? Wouldn't that help us to
Yes, that will
have a
us.
better?
Yes, in fact, Bcrypt and Blowfish are nowadays most of the people are using Bcrypt and Blowfish. But think about the legacy software, legacy applications that we have already created in the past, like 2 decades maybe. We have been already creating a lot of legacy products or legacy
Yes,
applications.
we have to migrate to keep it up to the challenge.
Yes, but
Yeah,
that
I can understand.
that's yeah. If you take it to your from the business perspective, business will never do that unless it is totally deprecated and people are determined that okay, we are doing it. We have to like for the banks and all. They are now using the recent algorithms and all. They are always anything is deprecated immediately. They have to move to the newer version of the encryption algorithms. But not always we need that, right? And when you have you are using a Windows system or a Linux system which is 2 years or 3 years old, of course they are using MD5 or SHA-1 because we really cannot cope up cannot upgrade the systems that frequently because it's not only there are a lot of other dependencies, not only the cryptography. Right, that's why we are still using MD5. In fact, more than half of the applications are still using MD5 because it's really is not possible to change it overnight. There
Yeah,
are
got. Uh, yes, it's not easy, but maybe we can gradually upgrade it.
gradually it happens like
Yep,
when
it happens only based on what the management thinks. They don't want to spend the money on it and time.
Is that because that is a overhead? And secondly, yes, it happens like when TLS 1.2 came. So of course the previous one, when the deprecated version, right now, I don't think many people are using the TLS one or SSL 1.1. Nobody is using nowadays. So it takes time, but it took almost 5 years for all the applications to move to 1.2. It takes time. Okay.
Yeah.
Now,
But
yeah. Okay, now we are good with the hash, and we know the biggest attack that can happen with hash is the rainbow table, and how we can solve that rainbow table attack. Now we are we are here. We already covered the Diffie-Hellman algorithm last day, so we don't need to go into that. We have covered this. We'll take a break for 10 minutes. What's the time now? It's 11. Okay, 15 minutes break we can take. We'll come back at 12 o'clock. We'll start with some mathematics, and then we'll learn about the RSA key, like asymmetric key cryptography, RSA, and elliptic curve cryptography, ECC. Okay, so this is
Okay.
yeah.
yeah. Please tell me. Okay. Okay. So this is the plan, and after that, after finishing the RSA, we'll quickly touch either the we'll see if we have time. We'll touch both quantum cryptography and blockchain. Otherwise, any one of them we'll touch today. Fine. I went really very slow for hash and all because I just thought that probably these things are required to be explained in a elaborative way. Is that fine, or it's too slow or too fast? Anything?
This is good, so much.
Everybody is understanding it. That is what I really want. Everybody should understand that at least the crux of this thing. Okay. Yeah. Let's take a break for 12 minutes break, and we'll come at 12 o'clock. Thank you.